Let's look at 6.3, which is all about matrix operations. So we have dealt with matrix, but we really haven't talked about notation. So we're going to talk about some notation. So we name matrix by their letter, like matrix A, B, or C, or any other letter. We talk about the entries inside of a matrix using like a letter, like this would be from matrix A, and then I is the row number and J is the column number. Okay, so it's very similar to how we do rows and columns when we name them. So I would be your row number and J would be your column number. So we can name the entry by looking at that. A general element in matrix A is denoted A subscript ij, refers to the ith row and jth column. The order of a matrix comes from how many rows it has by how many columns it has. So M is your rows, N is your columns. If you have the same number of rows as columns, it's called a square matrix. So let's look at our first example. We have matrix A. In order to know the order, we would figure out how many rows by columns. So there are 1, 2, 3 rows by 1, 2 columns. So this is a 3 by 2. Identify A1, 2. So you don't say 12. You separate the two numbers because it's talking about row 1 and then column 2. So A1, 2, row 1, column 2. So that's negative 12. Row 1, column 2. So negative 2. Identify A3, 1. So that's row 3, column 2. So row 3, column 1, sorry. Row 3, column 1. So A3, 1 would be 1. Find the value of the variables so that the matrix are equal. So this is talking about equality of matrix. So if two matrices are equal, if their corresponding entries or elements are equal. So if these two are equal, we would set the elements equal to each other. So row 1, column 1 is x. Row 1, column 1 is 6. So x equals 6. Row 1, column 2 is 8y. Row 1, column 2 is 24. So to find the value of y, you just divide by 8. Row 2, column 1 is z. Row 2, column 1 is 20, so z equals 20. And then the last one, it already tells us that they are equal, so 15 equals 15, which is true. Then the two matrices are not equal. If you get a matrix that the entries are not equal, then they are not equivalent. So it'd be kind of like a no solution there. Okay, we can add matrices, and the way you add or subtract matrices is you add or subtract the corresponding elements. So this gives you an example right here. If you're adding, you're just going to add the corresponding elements. So row 1, column 1, 1 plus a negative 1. And that's written right here, which is 0. Then you do row 1, column 2 is negative 2 plus 6. Negative 2 plus 6. And it goes in that same spot, which is 4. 3 plus 0 is 3. And 5 plus 4 is 9. Whenever you subtract, this is very similar to if you have a subtraction and then the parentheses where you have to distribute the negative or the subtraction. So you change the sign of everything in that second matrix, and then you can add them. Let's perform the operation on this example. So we're just adding. So we will add corresponding entries. You can write them out or you can do them in your head. I'm going to use corresponding colors to help me. So these are in the same spots, same entries. So I'm going to do negative 4 plus 6. It's positive 2. Three plus a negative 3. 0. 7 plus 2 is a 9. And negative 6 plus a negative 4 is negative 10. So you add corresponding entries. Let's look at the next example. It says find A minus C given A and given C. If an operation is not defined, state the reason. Can I add corresponding entries?
No.
Okay. Yeah, all except for
1 and 2.
Right, yeah. So matrix C is a 2 by 2, right? And matrix A is a 3 by 2. So they do not match up. They need to be the same order. So the reason would be not the same order. So let's go to the next one. Perform the indicated operation. So we're adding, they have the same order, so we're good on that. But there's subtraction. So you can choose how you want to do your subtraction. What I would do is I'm going to add and then change the sign of everything inside. That way I can make sure that I don't mess up with my signs there. So I have 5 plus 4, 9. 4 plus a negative 8, negative 4. Negative 3 plus a negative 6, negative 9. 7 plus 0, just 7. 0 plus 5, 5. And 1 minus 3. Okay, properties of matrix addition. So it's the same as the properties of adding real numbers. M by n matrices are 0. M times n, 0 matrix. And the following properties are true. So you can do the commutative property. So whenever you add, you can flip the order and it'll still be the same thing. Associative property of addition, it'll be the same. Adding a 0 matrix, which all the entries would be 0. That's the additive identity property. And then the inverse property. Those are all true. Scalar multiplication. So if you have a matrix, you can multiply every entry by the same number, which we call that number just a scalar multiple. And we can get a new matrix. So you'll multiply each element by that value. So our first example of scalar multiplication is -6 times b. So we have -6 times the matrix -1, -2, 8, 5.
Just multiply everything by 6.
Yeah, it's very similar to multiplying with distribution. So we'll multiply -6 times -1, +6. -6 times a -2, -6 times 8, -48. -6 times 5. Okay, the next is a type of equation involving matrix. It says 3a plus 2b. So 3a would mean I need to multiply 3 times everything here and then add it to 2 times the matrix b. So 3a is going to be 3 times -4, it's -12, 3 times 1, 3 times 3, and 3 times 0. So then it's 2b. So now multiply 2 times matrix b. And then we add them. And so that's what results. -14, -1, 25, and 10. We have similar properties for scalar multiplication. So associative property, identity, distributive, and the other one's also distributive, where you have your scalar inside. Okay, so let's solve an equation. It says solve for x in the matrix 3x plus a equals b. So what we can do is we can actually think about this and solve for x. Or we can set up an equation where we go ahead and plug in our matrices. But let's think about it as an equation where we need to solve it. What would be the first operation we would need to do to solve this? Subtract a. So it's b minus a. So why don't we go ahead and do that? So we're going to do 3x is going to be found by doing b minus a. So I have b. I'm going to do minus a. I'm going to put it on this side. So b minus a here. So like I did earlier with when I changed the sign, I added and changed the sign. You can do that. So let's find out what that would be. So b minus a is going to be negative 10 plus a negative 2. Negative 12. 1 plus 8. Negative 9 plus a 0. And 17 plus a negative 4. Yeah, positive 13. So I have 3x equals that now. What would be your next step? Right, yeah. So I have 3x equals b minus a. So I would divide by 3 to find out what x is. So I need to divide every entry by 3. To find out what the solution is for x. So negative 12 divided by 3 is negative 4. 9 divided by 3, negative 9 divided by 3. And then 13 divided by 3.
4.3.
Yeah, I don't know where 4 came from. Yeah, I meant to put 13 over 3. That's it.
Done for the day?
That is all we're going to do today. We'll do matrix multiplication tomorrow. So you have part 1 in Pearson.